Dear learners, I hope you have your pens and pencils, your jotters, and whatsoever with you, so as to study alongside with me. You are welcome, and I beg of you to subscribe to my YouTube channel if you have not. Still under circle theorems, and still on same chord, arc subtending angles at the center and the circumference of a circle. We are going to consider the part 3 of this same subtopic. There are so many things we have to take into consideration under this theorem so that learners may understand things well. For the sake of that, we are going to consider all the angles that are equal in value. So for now, I am going to move angle IED and place it on angle IDE, and you record your observations. I hope you see that. Oh, how beautiful GeoGebra is working here. Now you could see that angle IED is equal to angle IDE, as angle IED face equally on angle IDE, and that is what you see on your screen as point 1. We are going to draw a line to connect the point J on the circumference of the circle to the center of the circle, that is I. The line is drawn. There is something I want you to know. People believe that when a line is drawn like this one, line JI or IJ, they begin to think that then the angle has been divided into 2 equally. I want to tell you that it could be so, and it could also not be so. If it is divided equally, the question must indicate that. Apart from that, never think so. Now, when the line is drawn, we get 3 triangles. And when that happens, students sometimes get confused when they are asked to find any of the angles. So now let's look at it. I am going to move angle JEI and place it on angle IJD. If it fits equally, then they are equal. If otherwise, then they are not. So look at how beautiful it moves and turns around to be placed on that angle, that is IJE. And you see that it fits equally, meaning that these 2 angles are also equal. That is angle JEI is equal to angle IJE. So they are equal in value. If angle GEI is 30 degrees, then it means that angle IJE is also 30 degrees. Let's move on. Let me move angle JDI. And let's see what happens. See how beautiful it moves and how beautiful it turns. Good. We can see that it also fits equally on angle IJD. This means that these two angles are also equal. That is, angle IJD is equal to angle JDI. Let's see why it is so. Each one of the three triangles you see on the screen is isosceles triangle. And for isosceles triangle, two of the sides are equal. And in circle, the two sides that are equal are all radii. Hence, the bases of each triangle are equal. I am going to extend the straight line JI so that it passes through the angle at the center. So let's say that. Now we have line JM1. Let us understand that if the whole of the angle at the circumference, for instance, angle EJD, is half of angle EID, which otherwise means that angle EJD multiplied by 2 gives us the angle at the center. Then it means when the line is drawn, one of the angles at the circumference would be 2 times the angle at the center at the same side of the line drawn, that is JM1. I mean that when we multiply angle EJI by 2, we should get angle EIM1. And that is shown. Again, because angle EJI is the same as angle JEI, when we multiply this angle JEI also by 2, it should give us angle EIM1. Or when we add the two angles at the basis of the triangle, they should give us angle EIM1. When we move to the right side, the line has divided the angles into 2. So when we consider the one at the right hand side, that's, I'm talking of the angle at the circumference. When we multiply that angle by 2, it should give us the angle at the center and at the right hand side, that is DIM1. So you can say that angle D IM1 is equal to 2 times angle IJD, or because the angle IJD is equal to angle IDJ, we can also multiply angle JDI by 2 to get angle DIM1. Or again, you can add these two base angles of triangle JID to get angle DIM1. Let me move the angle at the circumference whilst you observe what happens. Look at it. The more I move, the smaller the angle at IGD. And when you multiply angle IJD by 2, you should get angle DIM1. In the same vein, when you multiply angle EJI by 2, it should give you angle EIM1. And it is also wonderful that when I move angle JEI and place it on angle EJI, it would fit equally into that. You look at it. Look at that. Good. And when I move angle JDI, it would also fit equally on angle IJD. You look at that. Look at that. Beautiful. I could shift it to the right side too. That's, I could shift the angle at the circumference to the right. You see that when I shift it to the right, the angle at the left hand side of the circumference and at the center, it becomes smaller. But still, when we multiply the one at the circumference by 2, it should give us the one at the center. So let me move them for you to see. I want us to explore it so that you may understand it very well. Good. You see that? You see that? Good. So, I hope this lesson would be of importance to you. Please subscribe to the YouTube channel for me. And let's move on to solve a question, at least a question, on this that we have learned today for better understanding. Question 1. In the diagram below, line FE divides each of the angles CFD and COD equally, and O is the center. Find I angle OFD, II angle COD, III T degrees. Let us solve it together. Because line FE divides the angle at the circumference, that is angle CFD into two equal parts, and it at the same time divides angle COD into two equal parts, we can say that for triangle FOC and triangle FOD, their bases are equal. Which means that angle OCF is equal to angle CFO, which in turn is also equal to angle OFD, and it is also equal to angle FDO, and they are all equal to 20 degrees. So you can write the 20 degrees at each of the angles to indicate their values, and that is what you see on the screen. Good. So right now we can say that angle OFD is equal to 20 degrees, and that is question I. It has been answered now. So we move on to II. For II, we are going to find angle COD. That is the angle at the center. So to do that, we add the angles at the circumference and multiply their value by 2. So that is what you see on the screen. Angle COD is equal to 2 times bracket open angle CFO plus angle OFD bracket close. So by substitution, we can say that angle COD is equal to 2 times bracket open 20 degrees plus 20 degrees bracket close. So when we add 20 degrees to 20 degrees, we get 40 degrees multiplied by 2. And then we have angle COD equals 80 degrees, because 2 times 40 degrees is equal to 80 degrees. Now it is left with the writing of that answer at the appropriate place in the circle. So that is also shown 80 degrees. Now we move on to our last question, which is angle T degrees. This is the T degrees, and we all know that a triangle COD is an isosceles, and therefore the bases are equal. So angle OCD is equal to angle ODC, and that is T degrees. So the base is T degrees, and that is shown on your screen. But we know that the sum of interior angles of a triangle sum up to 180 degrees. So we must add all of them and equate it to 180 degrees. So that is 80 degrees plus t degrees plus t degrees equal to 180 degrees. Then we have to simplify to get 80 degrees plus t degrees plus t degrees would give us 2t degrees equal to 180 degrees. And we have to group like terms. So we subtract 80 degrees from both sides of the equation so that we get 2t degrees at one side, and the other side we have 180 degrees minus 80 degrees to be 100 degrees. So we divide through by 2. 2t degrees divided by 2 would give us t degrees. 100 degrees divided by 2 would give us 50 degrees. So we can say that t degrees is equal to 50 degrees. Please subscribe to my YouTube channel for me. Today may be your first day of visiting this channel, but don't let it be the last. Please subscribe, share, and comment on the videos uploaded on YouTube. Let us look at the assignment. In the diagram below, O is the center of the circle. Angle FCO is equal to 20 degrees. Angle OCD is y degrees, and angle ODF is 32 degrees. Find I, angle CFD, II, angle COD, III, angle Y degrees. Please pause the video, solve for the values of the angles indicated in the question, and you compare your answer with that of mine to find out if you are correct. So that the answers are I, angle CDF is equal to 52 degrees. If you had it, well done. Angle COD is also equal to 104 degrees. Congratulations. And angle Y degrees is equal to 38 degrees. I congratulate all of you for scoring at least one of these questions. Please subscribe to this channel for me. I hope we meet again on this same channel on different days. May God be with you till we meet again. Bye.